All right, we're going to record, or we're going to rotate. We rotate the region R2 around AB, and we're going to try to find the volume of that solid. Now, AB is a vertical line, and let me darken that or highlight that. No, just sort of darken it, making that brighter. So that's AB, and we have this region R2, and we're going to rotate around that. So maybe I'll copy this over here and show that rotation. I sort of want to, in fact, sort of eliminate all the other stuff in my picture, so I'm not distracted by all those other things. So I have R2, and it's just what I have over here. And now R2, although I sort of got carried away on that. Well, okay, maybe I'll just leave it like that for a moment. All right. This is what the rotation looks like, something like this. And what's going on is that if you make a cut, a slice, you get a circular disc with a hole in it, and that's what we call a washer. And when we find the volume is, okay, so the height here is dy. So that's one reason to actually draw this, is that we see the height is dy. And I'm going to integrate from C to D, and I integrate the area function. Now, what's the area function? Well, the area is going to be determined using the formula pi r squared for the area of a circle. So it's going to be pi r squared, but we subtract the smaller circle, so that's also pi r squared. Now, this is all being rotated around the line x equals 1. So that's the line x equals 1. So what is the radius then? The radius will be the distance between the line x equals 1 and, well, let's see on the left here, x equals 0. So this is x equals 1 and x equals 0. So we can see the larger radius is 1. It's going to be 1 minus, sorry, it's going to be 1 minus 0. And now there's another radius, that smaller radius. I'm going to take 1 and subtract the function. Now, the thing about this function is that it says y equals the 4th root of x, but I want to write that function as x equals y to the 4th, because I'm integrating with respect to y. So I'm going to have 1 minus y to the 4th right there. This is my small radius. All right, okay, let me point something out, is that I have a formula that you could just plug everything into. So my formula is V is the integral from C to D, f of y minus L squared times pi, minus pi g of y minus L squared dy. And this f of y is the outer, this is the inner. X equals L is a vertical line, which is the axis of rotation. And even here, since I already put in 1 and y to the 4th, let me change these bound numbers to y values. And the y values we can see that we're bound by are 0 and 1. So you have that formula, you can just plug into just put that into the formula. So you have that formula, but we're going to have v equals pi. I'll factor out pi 0 to 1. I'm writing f of y minus L, but you can write L minus f of y. But 1 squared is, it's obviously 1. And then I have 1 minus y to the fourth, but that's the same thing as y to the fourth minus 1. And then I will expand that. 1 minus y to the fourth squared is y to the eighth minus 2y to the fourth plus 1. Well, I'm sort of thinking I reversed everything. What the heck? It looks like I have a problem that I'm going to get a negative. No, I'm not going to get a negative. I was panicking. I'm going to distribute this negative and make a positive. Okay. I had a little bit of a panic there that I wasn't doing it right. Maybe I'm not, but at least this part isn't wrong. Okay, so negative y to the eighth plus 2y to the fourth. Okay, so there's a positive there. I have to have a positive number for volume. Can't have negative. Okay, so I'll have negative y to the ninth over 9 plus 2y to the fifth over 5 from 0 to 1. All of that times pi. So that equals pi. Putting in 1 gives 1/9 plus 2/5. But I think I dropped a negative. There's a negative 1/9 plus 2/5. And then putting in 0, you just subtract 0 and get 0. So this is going to be pi. And then to get a common denominator, I have negative 5 over 45 plus 18 over 45. Somehow I feel like I might be leading up to a wrong answer. And so this is number 25 on section 6.2. No, that's right. That is correct. All right. Okay. So that was something. That was a difficult problem in a way. All right, let's finish up that.